Hi, I'm Adriana.
Hi, I'm Daniel.
Today we'll be representing VMC's OnStage RoboCup Team Generation Bot.
The inspiration behind this project comes from my interest in robotics and how they are increasingly being used in different ways in our everyday lives.
We truly believe that humans and robots can work together to create a future that is better for everyone.
The performance focuses on four main sectors and how robots and machinery are being used to extend the capabilities of workers in those fields.
Today, we'll be presenting to you the four main features of our performance as well as the design process and challenges that were experienced while developing them.
We use two different types of robot kits for this project. The first one is LEGO Mindstorm EV3 robots. we have four of these robots on stage during the performance. This robot works with the LEGO Mindstorm EV3 program, a block-style coding software.
The second type of robot that we used was the LEGO Inventor Kit. This is a newer model that we had the chance to experiment with. It also works using a block-style coding language.
The benefits of using these kits is that the robot hub will run on a rechargeable battery.
The robots are also completely constructed using Lego pieces, allowing for the original design of the robot to change as different features are added and modifications are made. This allowed us to practice sustainable development while completing the project. Feature 1: Image Recognition. The purpose of the image recognition feature is to show the features of machine learning and how the robot is able to recognize objects in its environment and react accordingly. He will be discovering each of the individual sectors at the same time as the audience.
The image recognition was accomplished using a cell phone camera that communicates with a laptop on a shared Wi-Fi network. The app being used to make the connection is called Irwin Camera. It sends video footage to the computer where the software machine learning model can make interpretations.
The LEGO Inventor Kit robot is programmed to scan each image from left to right as they sit on the stage. Every time our robot performs, we calibrate the images by taking pictures of the four posters and retraining the model to classify them as either being healthcare, education, aeronautics, or military.
Challenges experienced while developing this feature included the model not being able to properly detect different classes. Originally, we had used the main model and added a new image for each performance. Through experimentation, we discovered that a smaller dataset that was made at the time of each performance was more effective as the images had the same lighting and surroundings as the footage that the robot would be seeing. Feature 2: Prop and Robot Interaction / Avoidance.
Robot-prop interaction was integrated into the performance to allow the robot to adapt to performing on different stages and to avoid collisions with any of the other robots.
Each of our LEGO EV3 robots are equipped with an ultrasonic sensor programmed to make them stop and turn around if they are ever in close proximity to another object, such as the poster they are placed in front of.
The robot moves towards and away from the poster when triggered by a timer. In this way, the robot does not have to be programmed to move by distances, but rather is more autonomous and has the ability to adapt to its surroundings. For example, if the poster was placed closer or further away.
When practicing on different surfaces, we observed that the robot's movements behave differently due to different levels of frictions on the wheel. For example, the robot was programmed to make a 180-degree rotation when it came in contact with a poster or object. To make our motions more precise and reliable, we decided to use a gyro sensor on the robot.
A block that allows programmers to input a target value. The robot will then rotate until this measurement is reached. The speed of the robot is also controlled by a second value that will make the robot slow down as it reaches its target. It is important to note that a separate program resets the value to 0 before executing this, thus calibrating the gyro sensor. Feature 3: Robot-to-robot interaction / Bluetooth messaging. This is a new feature that was added to our performance recently. Not only does it help our robots to perform in sync with each other, it also shows the audience how the robots are able to work together to solve problems. Many of the sectors presented can be combined in creative ways to benefit others. For example, sophisticated simulators used in education can help to train better healthcare workers.
A program was built in which the first main robot sent a message to 3 other worker robots. This occurs twice in the performance, once at the beginning to send signals to start a timer on each robot, and at the end to move each robot forward for the final position.
Our group only consists of 2 members. Using Bluetooth was used to solve the problem of having to start all of the robots at the same time.
Feature 4: Robot and Human Interaction.
The main theme of our project consists of the relationship between man and robot that is constantly evolving. We want to show the audience just how helpful a robot can truly be to human life. It is for this reason that we also added human interaction to our main robot as a simple example. He and the human on stage exchange the globe to show how our world is constantly evolving and has a need for both robots and humans alike.
A few extra parts were added to the robot in order to be able to accomplish this. The robot is equipped with an ultrasonic sensor to detect when someone is near him, a color sensor to be able to recognize a blue ball, and a moving arm made of Lego pieces that's able to grasp and handle objects.
The robot is instructed to wait for a human to activate him at the beginning of the performance. This is mirrored at the end of the performance where the robot is guided by human interactions to carry out the final scene. He opens and closes his mechanical arm when his ultrasonic sensor is approached. Likewise, he also prepares to grasp a blue ball when he sees the color using his color sensor.
With all the new parts added to the front of the robot, his weight became unbalanced. We had to add an extra weight behind his wheels to ensure that he would not fall during the performance.
We hope you enjoyed this quick technical explanation of our presentation, Generation Bot. Stay tuned for our presentation to discover more about the future of robots.